Unit 4, Quadrilaterals and Polygons, Lesson 2, Parallelograms, Part 2. Your objective for this lesson is to use properties of parallelograms to prove that a quadrilateral is a parallelogram. Okay, so let's cover this up. Recall from Part 1 of this lesson that if both pairs of opposite sides are parallel, both pairs of opposite sides are congruent, both pairs of opposite angles are congruent, the diagonals bisect each other, or if one pair of opposite sides is congruent and parallel, so any of these 5 situations, then your figure that you're looking at is a parallelogram. So 5 different ways to show that what you're looking at is a parallelogram. Okay, example 1. Find x and y so that FGHJ is a parallelogram. Well, I'm looking at some sides, so I think I'm going to use this second one if both sides are congruent, because that's going to be the easiest thing to do here. So I want to show that 15 is equal to 6x plus 3. So 15 equals 6x plus 3. This equation, when it is true, will make these sides congruent. So if I'm going to solve, I'm going to subtract 3. And I'm left with 12 equals 6x. Now I'm going to divide by 6, and I get x equals 2. Okay, so that is the value that will make my two opposite sides FG and JH congruent. But I also need to find the value that will make these two sides congruent. So 4x minus 2y has to be equal to 2. I just found that x is 2, so let me substitute that in. 4 times 2 minus 2y equals 2. 4 times 2 is 8, minus 2y equals 2. Okay, now I'm going to subtract 8 from both sides. And negative 2y equals negative 6. But y still isn't by itself, so we need to divide by negative 2. Okay, so y equals negative 6 divided by negative 2 is 3. Okay, so what we just did, we wanted to find the values of x and y that'll make this a parallelogram. For that to happen, the opposite sides have to be equal. So we set up equations equating the opposite sides and solved for x and y. So when x is 2 and y is 3, FGHJ will be a parallelogram. Example 2, we have a coordinate proof here. We want to determine whether or not ABCD is a parallelogram. And we've been given the coordinates of the vertices A, B, C, and D. These are the coordinates. And looking back at our different criteria here, we're going to look at the sides again. But there are 2 things in the coordinate plane that we can use to show that this is a parallelogram. We can look at the opposite sides to see if they are parallel by using the slope formula, or we can see if they're congruent by using the distance formula to find the length of each. So we're going to do both methods here since this is our last example for this part. So method 1 is use the slope formula. Okay, and the slope formula, remember, is m equals y2 minus y1 divided by x2 minus x1. So I'm going to find the slope of each of the four sides here. Let me mark the vertices on the plane here. Okay. And I'm going to label x2s and x1s. So let me start off with AB. Okay. So this will be x1, y1, x2, y2. So according to my slope formula, I need to have y2, that's my 2, minus y1 is 3, over x2 is 3, minus x1 is negative 2. Minus negative is a plus, so I'm going to write a plus. 2 minus 3 is negative 1. 3 plus 2 is 5. So my slope of AB is negative 1/5. Okay, so what I want to check is to make sure that the opposite side, DC, has the same slope. So it needs to be negative 1/5. So I'm going to go ahead and move my labels down to C and D and plug in again. Now my y2 is negative 1 minus y1 is 0 over x2 is 2 minus x1 is negative 3, so I'm going to change that to a plus 3. Negative 1 minus 0 is negative 1. 2 plus 3 is 5. So I have the same slope. These are both negative 1/5. That's a good thing. Okay. But I need to show not just that AB and DC have the same slope, but also that AD and BC have the same slope. So let me finish up with those. BC, I'm going to move my label up to B. Okay. Y2 is negative 1 minus y1 is 2 over x2 is 2 minus x1 is 3. Negative 1 minus 2 is negative 3 over 2 minus 3 is a negative 1. In simplifying this, negative 3 over negative 1 is just a 3. Okay, so if AD or DA has a slope of 3, then we'll have a parallelogram. Let's see if that is going to work out for us. So AD. And I need to move both of these labels. Okay. So y2 is 0 minus y1 is 3. So 0 minus 3 over x2 is negative 3 and x1 is negative 2. So negative 3 minus negative 2 is plus 2. Okay, so this gives me negative 3 over negative 1, which, as you see, is the same thing I have right there. So this also simplifies to a 3. These are the same, which is what we want. Okay, so we could conclude, since opposite sides have the same slope, they are parallel. And then you could say a quadrilateral with two pairs of parallel sides is a parallelogram. And this is what I would conclude here. Okay, let's take a look at method 2. So method 2 now, we're going to not show that the opposite sides are parallel, but that they are congruent. And we're going to do this with the distance formula. So use the distance formula. Okay. And remember that the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So I'm going to start off like before. I'm going to find the length of AB. And I'm going to label x1, y1, x2, y2. So what I'm putting under my radical is 3 minus negative 2, so plus 2, squared, plus y2 is 2 minus y1, 3, squared. And I'm going to simplify this. You could also do this in your calculator. So 5 squared is 25, plus negative 1 squared is a positive 1. So I have the square root of 26. Okay, that is how long A is. I'm going to write that on here. Next, I want to see if CD is the same length as AB, because if it's not, then I definitely don't have a parallelogram. I'm just going to stop. So let me find CD. So again, I'm going to have the square root of x2 is 2 minus x1 is negative 3, so plus 3 squared, plus y2 is negative 1 minus y1 is 0 squared. Okay. 2 plus 3 is 5, so we have 5 squared plus negative 1 minus 0 is negative 1 squared. And you can see this step is the same as the step up here. So we should end up, and we do, with the same answer. So this is still the square root of 25 plus 1, which is the square root of 26. So square root 26. So far, so good. We have to find BC and AD next. So I'm going to move my label up here. I'm going to write in blue for these two sides. So BC, we have the square root of x2 is 2 minus x1 is 3 squared plus y2 is negative 1 minus y1 is 2 squared. 2 minus 3 is negative 1. Negative 1 minus 2 is negative 3. Okay. And this gives us, well, negative 1 squared is 1, plus negative 3 squared is 9. Those numbers should both be positive. If you got a negative number there, your answer is not going to be right. This is the square root of 10. So this side length is square root 10. The last side we need to find is AD. And if this is not square root of 10, then we don't have a parallelogram. If it is, then we do. So AD. Square root of, let's see what x2 is. Negative 3. And x1 is negative 2. So we have negative 3 minus negative 2 is plus positive 2 squared, plus my y2 is a 0, y1 is 3, so 0 minus 3 squared. So negative 3 plus 2 gives me a negative 1. And 0 minus 3 is a negative 3. Okay. And negative 1 squared is a positive 1. Negative 3 squared is a positive 9. And this gives me the square root of 10. And since these match, so I have two square root 10s opposite each other, and these match, I have two square root 26s opposite each other, we do have a parallelogram. So my conclusion here would be, since opposite sides are the same length, ABCD is a parallelogram. And that would be my conclusion here. Okay. So in this section we looked at proving that figures are parallelograms, and we did a coordinate proof 2 different ways. Both ways would be acceptable answers on a test. And we reviewed criteria for determining if a quadrilateral is a parallelogram. And that concludes lesson 2, part 2.